Okay, sir. Jagannath sir will make you as a presenter, sir. We made you as a presenter. Okay, thank you, sir. Just few minutes, sir. We'll start.
చూస్తాను. Good evening to all the participants and hearty welcome to a one-week online international workshop on mathematics, bridging ideas and innovations, MBII 2024 from 16th to 21st December 2024. In the fast-growing field of engineering, computational skills have become the cornerstone of innovation and progress. Thank you all participants for joining with us to get an immersive experience that goes beyond textbooks, equipping you with the tools to navigate real-world challenges through the lens of advanced mathematics. This international workshop will definitely redefine the way in which the students pursue and apply mathematics in their engineering journey. The aim of this international workshop is to bring some sort of awareness and enlightening the knowledge on mathematics of machine learning, lifelong learning in the era of AI, some aspects of statistical hypothesis verification, numerical methods for engineers and scientists, data visualization of mathematical concepts. This week is a special week for all of us in which 137th celebrations of a great mathematician, Sri Srinivas Ramanujan, in view of his birthday on December 22. He is one of the greatest mathematicians of India. Ramanujan's contribution to the theory of numbers has been profound. He was indeed a mathematical phenomenon of the 20th century. This legendary genius of India ranks among the all-time greats like Euler and Jacobi. Sri Srinivas Ramanujan's life remains a remarkable role model of innate mathematical genius, overcoming challenging circumstances, leaving an indelible mark on the world of mathematics. I now request humbly our senior faculty member and professor of maths, Dr. P. Vijayasarthi sir, to complete the program.
Thank you, Bodhra sir. A very warm and healthy good morning, good evening to our respected principal, Dr. Nazir Sheikh Garu, Bapatla Engineering College, Bapatla, our beloved HOD, Dr. K.V.N. Acharya Garu, today's revered resource person, Dr. L. Jagannathan Garu, my dear colleagues and participants. I would like to welcome you to all to this international workshop conducting in view of celebrating 137th birth anniversary celebrations of a great mathematician, Sri Srinivas Ramanujan, on December 22nd. Sri Srinivas Ramanujan was one of India's greatest mathematical geniuses. He made substantial contributions to the analytical theory of numbers and worked on elliptic functions, continued fractions, and infinite series. His life and work continue to inspire mathematicians and scientists. Moreover, his life is often cited as an example of extraordinary mathematical intuition and talent. To pay our homage to him, the Department of Mathematics, Bapatla Engineering College, is organizing a one-week online international workshop on mathematics, bridging ideas and innovations, MBII 2024. This program is scheduled every day from 3 p.m. to 5 p.m. from 16th to 21st December 2024. More than 1,000 students have registered from various educational institutions across the state for this workshop. Now I request one of our staff organizers, Dr. N. Balaya, to present the department profile.
Respected head of the department, Dr. K.V.N. Acharya Garu, my dear colleagues and participants. Good evening to one and all. It is my privilege to present the department profile. The department was established in the year 1981, in which the college was started. The department, which was originally intended to cater to the needs of engineering, offered MSc Mathematics course with an intake of 40 students in 1989. The department was recognized as a research center by Acharya Nagarjuna University from the academic year 2003 to 2004. So far, the department produced 3 PhDs and 13 MPhils. The department was recognized as one of the potential departments in 2002 by the National Board of Higher Mathematics. And as a part of it, the department has been receiving quality books in mathematics. The department is now enriched with 5 PhD faculty members from different universities. The college library has a collection of 1405 titles and 5188 volumes. Out of 32 MSc passed out batches, 12 students achieved university first ranks and 4 students obtained university second ranks. 2 students received Pratibha Awards. For last 1 decade, 200 research papers were published in national and international journals. The major contribution has been given by Dr. K.V.L. Acharyalu sir with 150 research articles and Dr. N. Rafi sir with 66 research articles. Faculty members in Department of Mathematics attended more than 150 FDPs, workshops, conferences, or seminars. Notable achievements are accomplished by the faculty members. In particular, Dr. K.V.L. Acharyalu sir created 3 unique world records in the field of mathematical research and honored various international publications. Dr. K.V.L. Acharyalu sir edited more than 150 books as editor-in-chief of
Is my audio visible or audible?
I am for sharing your department profile.
Sir, 1 minute, sir.
Now I would like to bring to your kind attention on the objectives of this workshop. First, to foster a culture of continuous learning in student community by familiarizing the applications of mathematics in various fields of engineering.
Sorry, sir.
To enhance the problem-solving skills and logical thinking capabilities of students through expert lectures of resource persons from national and international universities. To convert young engineers into strong individuals in order to face the real-world challenges by exposing them with variety of lectures, both in mathematics and statistics in different domains. Now, brief information about this international workshop. On the first day, that is 16th December 2024, Dr. L. Jagannathan Garu, Professor, School of Computer Science and Engineering, Vellore Institute of Technology, Chennai, will deliver a talk on mathematics of machine learning. On the second day, that is 17th December 2024, NVRD Kumar Garu, Senior Faculty, Department of General Education, Khalil University College, Sharjah, United Arab Emirates, will deliver a talk on lifelong learning in the era of AI. On the third day, that is 18th December 2024, Dr. T.S.R. Murthy Garu, Professor, Department of Mathematics, Sri Vishnu College for Women, Bhimavaram, will deliver a talk on some aspects of statistical hypothesis verification. On the fourth day, that is 19th December 2024, Dr. P. Nagarani Madam, Associate Professor, Department of Mathematics, the University of the West Indies, Mona Campus, Jamaica, West Indies, will deliver a talk on numerical methods for engineers and scientists. On the fifth day, that is 20th December 2024, Dr. T. Ramalingeswara Garu, Senior Data Scientist, Advanced Quant Analytics, IQA, PFSI, A&I, TCS, will deliver a talk on data visualization. On the last day, that is 21st December 2024, Dr. M.A. Srinivas Garu, Professor Emeritus, Department of Mathematics, JNT University College of Engineering, Science and Technology, Hyderabad, will deliver a talk on visualization of mathematical concepts. Now I request our beloved head of the department, Dr. K.V.L. Acharyalu Garu, to address the participants on this occasion. Sir, please.
Sir, I request the organizing team, please check the audio, sir, because some disturbance resounds are coming.
Maybe two devices are nearer together, might be.
Sir?
Two devices might be nearer to each other because of that.
Sir, so
Am I audible?
please mute your device, sir. Sir, can I start, sir? LJ, sir, can you hear my voice, sir? Or is there any resound?
Yes, sir. Yes, I can hear you. I can hear you. I can hear you.
Okay, sir. So, good evening to all. On behalf of the Department of Mathematics, I humbly welcome all of you to this international workshop. I extend a warm and heartfelt welcome to my respected teacher, Dr. L. Jagannathan sir, my esteemed colleagues, and my dear students. It gives me immense pleasure to take this opportunity to say a few words as a convener of this international workshop on behalf of the Department of Mathematics, Bapatla Engineering College, on this memorable occasional week of the birth anniversary celebrations of Sri Srinivasa Ramanujan, who is applauded as a world greatest mathematician. Sri Srinivasa Ramanujan made significant contributions in the field of mathematics, particularly in mathematical analysis, number theory, infinite series, and continued fractions, etc. He independently discovered many theorems and results that were later proven by professional mathematicians. Ramanujan's legacy is marked by the Ramanujan's Hardy number, Mach theta functions, Ramanujan's prime, and various other mathematical concepts named in his honor. Hence, based on his valuable contributions to the field of mathematics, we are celebrating his 137th birth anniversary celebrations on December 22 in this week as National Mathematics Day. It is my bounden duty to express my special gratitude to our magnanimous management, particularly Sri Muppaleni Srinivasarao Garu, President, Bapatla Education Society, and Sri Mana Nageswarrao Garu, Secretary, Bapatla Education Society, and other governing body members for their valuable encouragement to organize student-oriented useful programs. We are all thankful to our beloved principal, Dr. Nazir Sheikh Garu, for his timely guidance and valuable support whenever necessary. We feel very proud to work with him and render our services under his dynamic leadership for enriching the name and fame of our Bapatla Engineering College. The main purpose of conducting this international workshop is to focus on enhancing the computational skills in students' community in various fields of engineering. No doubt, improving computational skills is crucial for all BTech students. Our revered resource persons can share insights into how computational skills are applied in real life situations, motivating students to improve their skills. By combining theoretical knowledge with practical applications and explore to real-world challenges, BTech students can develop strong computational skills that are essential for getting success in their respective fields in future. Hence, developing problem-solving skills and a deep understanding of computational principles will enable the students' community for facing and handling the challenges confidently in their engineering fields. So I strongly believe that this program will be definitely a fruitful one with the active participation of our sincere students. Today, we have a wonderful resource person with us. The resource person for today's section is Dr. L. Jagannathan sir, Professor, School of Computer Science and Engineering, Vellore Institute of Technology, VIT Chennai. He is one of my best teachers in my students' career. Dr. Jagannathan sir is not only an inspiring teacher, but also a source of motivation, guidance, and unconditional support to the students' community. I had a good association with him as his student and also as a colleague. He rendered his valuable services to Bapatla Engineering College from 1994 to 2004, more than 10 years. He inspired plenty of students in his career with his best way of teaching and good qualities. On behalf of Department of Mathematics, I express my sincere thanks to Dr. L. Jagannathan Garu for graciously accepting our request to deliver his valuable lecture in our international workshop. Thank you, sir. Thank you very much. All the best. Thank you, one and all. Sir. Sir, your voice is not audible, sir. Please check. Sir? Sir, if I am talking, I am getting resound, sir.
When the gadgets are nearby, that sound may come.
Sir, try to make distance between two devices, sir.
Thank you, sir. Due to urgent college work, our esteemed principal, sir, will not be able to attend today's international workshop. However, he has conveyed his heartfelt best wishes to all of us. He appreciated the Department of Mathematics for organizing such student-oriented programs with exemplary teamwork. Sir also encouraged all participants to attend the sessions wholeheartedly and make the most of this opportunity to enhance their knowledge. Wishing all of us a fruitful and enriching experience. Thank you, sir, for your inspiring message. Now, this is the time to know about today's resource person. Now, I request one of our staff organizers, Srimati K. Nagamani, to present the profound profile of Dr. L. Jagannathan Garu.
Good evening, all. Welcome you all to a online international workshop on mathematics, bridging ideas and innovation. It's my privilege to introduce today's resource person, Dr. L. Jagannathan Garu. Dr. L. Jagannathan is a senior professor of higher academic grade working in the School of Computer Science and Engineering, Vellore Institute of Technology, Chennai. He obtained his PhD from Indian Institute of Technology, Madras, with specialization in theoretical computer science. He is a passionate teacher, having explored many learning methodologies like ZA approach, project-based learning, research-based learning, flip the class, etc. His courses are oriented more towards triggering the young minds to think, and all his course related assessments are a real minds on sessions. With his 33 years teaching experience as an educator, his present research focus is on AI for education. At present, he is working in a mighty funded project to develop AI tools to facilitate education in a more better way towards making the concept education for all a reality. Professor L. Jagannathan sir is applauded by one and all with his best way of teaching for the last 3 decades. He published many research articles in journals and conferences. He took an active part in design and development of some new courses and a center of excellence and rendered valuable services to the college in different positions as head and dean. His inspiring character, motivational behavior, teaching abilities, research capabilities, extraordinary communication skills are additional qualities in him apart from his goodness and vast experience in the field of education. Thank you all.
Can I start now? Can I start? Is my screen visible? Can I get a response, please?
So, dear participants, I know that you are all eagerly waiting for the lecture on mathematics of machine learning. Hence, I will hand over the session to Dr. L. Jagannathan garu.
Okay, fine. Thank you, sir. Thank you for the introduction. And first thing, is my audio clear to you?
Sir, can you hear me?
I can hear you.
Sir Jagannathan, sir, can you hear me?
I can hear you. Can you hear me? Can you hear me? Can you hear me? Hello? Hello, can you hear me?
Sir, LJ sir,
I can hear you.
sir, have you joined in both devices, sir? Cell phone and laptop?
Which one, sir?
So have you joined in 2 devices, sir? Because coming disturbance, sir.
No, I am joining only one. Only
Sir?
one. Only one. Other tab is closed. Only one.
Okay, sir. Okay, sir. Okay, sir.
Now, are you able to hear me?
Sir, but we are hearing, sir, but some resound is coming.
Resound I am also getting now. How is it?
No, sir.
Now, how is
Sir,
it?
your voice is okay, sir.
Now, how is it?
Fine, sir.
But resound, I am having only one device here and no disturbances, nobody inside the lab also.
Okay, sir. Thank you. Thank you.
Is it audible now?
Yes. Yes.
Yes, sir. Yes,
Okay,
sir.
fine. And is my screen visible now?
No, sir.
Not sir. No, sir. No.
Now?
We are seeing your desktop. Yes, yes. Now it is
Now it
visible.
is.
You're able to see it?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Okay, fine. So the agenda for, if there is any disturbance and other things, please unmute yourself and tell me instead of putting in the chat because I may not view the chat properly. So if there is any disturbance, let me be very slow. The agenda, I will make it out very clear. The agenda for today's session is going to be first, we will be doing. So first, you are able to see my whiteboard. You are able to see my whiteboard, I think. Hello? Are you able to see my whiteboard or not?
Yes, sir. Yes, sir.
Okay, fine. So first agenda is what is ML? First, ML wise slightly for a few minutes, 2 or 3 minutes we'll be discussing. And what is actually ML? Because the topic is related to mathematics of machine learning. So usually if you paraphrase it, first what is learning, what is machine learning, and what is mathematics of machine learning. In that way the discussion will go. And so what are the main core theme which we'll be discussing for next 90 minutes is going to be the idea behind the idea behind the machine learning algorithm. What is the concept? How the mathematics which you study in your mathematics course is going to help you in developing an algorithm to do the task with machine learning. That is the idea of it. So first, to set the trend for the talk. First, we will be having a short discussion about MLY, ML what. After that, we will be getting into the major learning models related to regression and classification. After that, we will be discussing what is the mathematical concepts. The concepts are mostly related to linear algebra, calculus, or probability statistics. Based on the time permission, how much time we can have a discussion, but we'll have a deep discussion in every aspect. That is the only thing. So I am planning for 4 or 5 models concept to make it threadbare with all the derivation and other things, so that you can have the real-time feel of that algorithms. That's the aim of this. So mathematics of machine learning means what? What is the mathematics behind machine learning model? That is the agenda. Now we are going to have it. First, hope everything is clear. Please, if there is an audio disturbance or any kind of disturbance, please unmute and raise your voice through our audio. Don't hesitate, and don't put in the chat that it's not audible or something, please. So usually what for the engineers, I am going to address, I assume that, not assumption, I am addressing the BTech students. What is the main bread and butter of BTech student is, the engineers are, what is the main thing? Solving a problem. Main aim of it, though I have written it for computer scientists, and it is applicable for any engineer. To solve the problem using computer, we require programs which enter algorithm to solve it. So how the doctor is to the patient, in the same way engineer is to problem actually. Problem solving is the bread and butter of any engineer. Like treating the patient is the bread and butter of a doctor. In the same way, problem solving is the main thing. Okay, what is the problem? It is just a description. I will be going from the scratch. Sometimes it might be boring, but bear with me. So what is the problem? It is a textual description which contains what is the input and what is the expected output actually. So for the sample problem may be given the level of groundwater table, population of the locality, rate of growth of the population, number of borewells in the locality, individual daily consumption, quantity of water, forecast of the year by which water will be. Based on the inputs, we have to predict the year by which water will be sufficient for the residents in a particular locality. And given the description of a car, predict the period by which resale price will be maximum. I have bought a car, I want to sell it after a certain year so that I get a maximum profit. So given the descriptions of the car, I have to do some calculations. I have to predict by which year, if I sell it, it will have it, like a stock price actually. So to like that, to diagnose the disease with the symptoms provided by the patient. Like the doctor diagnosing the illness of the patient based on the symptom, my machine learning algorithm will diagnose the disease of the patient, like that. These are the problems actually. Now, what is there anything unique in this problem? Can I have some reaction from that? What is unique in all this problem? Anything unique in this problem? Anything unique? Any common chain going across along this problem? The first problem is these two problems, given the level of groundwater table and other thing, given the description of the car, period by which resale price will be maximum, and this family tree problem. Starting from for 100 years, I am having the birth and death of all the people in my family, predict the longevity of the person who will be born in the 100th birth, like that, to develop a chatbot in a specified language, the natural language, to diagnose a disease. What is the main thing here is, there is no clear-cut procedure to solve this problem. That is the main thing. That is, every problem will have their own method and subjectiveness involved. For example, given the level of the groundwater table, all these things, it relates to a particular locality. There is no single formula to predict the groundwater table. And in the same way, for the given the description of the car, can you predict by which resale price will be maximum? There is no other. For example, I want to buy a house in Bapatla. Okay, very good. How much does it cost? Is there any formula to compute the selling price of a land or selling price of a house? Based on the market, the people will say that the market trend is very heavy, sir. But nowadays, the rate has gone up. And how to capture the mood of the society? Yeah. Hello? Any disturbance?
No disturbance, sir.
Hello?
Yes, sir.
Am I audible or not? There was some people
Yes, sir.
talking.
Yes, sir. Yes, sir. Yes, sir.
Okay, fine. So now what is the what is the problem in all these things? Subjectiveness. There is no single formula to predict. Like given the base and height of a triangle, you can predict, you can calculate the area of a triangle. There is no clear-cut procedure to solve this problem. So when there is no clear-cut procedure to solve this problem, we have to collect the data. Based on that, we can do it. So machine learning comes to solve the problem which are having high subjectivity. Objectivity means what? If the pass mark is above, if for a student to get a pass, he should have scored for above 40 marks. This is a clear objective formula. And you want to compare all the characters and give a pass mark, mean that is a subjective formula. So how to solve this subjective formula? All the real-time problems are subjective only. It is not mathematically oriented, having a clear-cut formula. So how to solve this problem? And what will happen if you don't solve this problem? If you don't predict the groundwater table in a particular locality, on one sudden day there won't be any water in the ground, and the people will suffer from water shortage. That's the only thing. We'll be facing the worst case scenario here in this thing. So first message through this session is machine learning problems are there to handle the problems which are subjective in nature. Hope you get the meaning between subjective and objective. Objective means where there is a clear-cut formula. Subjective means there is no clear-cut formula. That is something like it, how the price of a land is fixed in a particular locality. Nobody knows. Sir, it is nearer to the shopping complex, nearer to the school. Like that, everyone will have their own version actually. So we have to collect what is how the lands are sold for the past 10 years or 15 years. From that data, we have to learn something and do it. That is the main objective. So machine learning can handle all the problems which are subjective. This is the first message. Then second message is what is actually a machine learning? So we go to the second slide. Because I'm having a bunch of slides. Based on that, I will project it actually. So now coming back to the thing. And what is learning? So now what is the first agenda is what is the first agenda? Machine learning is there to help the problems which are subjective in nature. First thing, very good. Now what is machine learning? So here again, what is machine learning? What is learning? Those things and all will start actually. So thus machine learning handles the problem whose process of solving involves subjectiveness. Even the doctor, how do they diagnose our disease? Based on the symptoms which we give, they have their own mechanism and diagnose it. Given the same symptoms, two different doctors diagnose two different illness of a same patient. That happens. So here the doctor diagnosing problem is highly subjective. You give the symptoms to a Dr. A, the same symptoms to Dr. B. The Dr. A will diagnose one illness and Dr. B may diagnose another illness actually. So that is the best example I can give you to understand the subjectiveness. So now what is machine learning? Actually, what is the learning? If you go to as a teacher, what is learning? The thing is, I teach in the class and the students should understand that and practice and they gain something that is called learning, the teacher will say. And psychologist, he'll go on talking to the patient again and again till the behavior of the psychologist is getting changed. That is the learning in the perspective of psychologist. Okay, what is the engineering perspective? They read the theory and they apply what they learned to solve a problem. That is the engineer's perspective of the learning. What is the learning from the medical doctor's perspective? They get the symptoms, they analyze different cases. Based on that, they learn certain thing and to treat a new illness. That is the way the world reacted when the pandemonium broke. Because before that, there is no pandemic, coronavirus, those things and all. So they had their own learning and make it. So there is no common definition for a learning. That is one thing. So now if a computer scientist has to write a program for learning, on what basis he will write it, that is a big question mark. For example, if I want to automate the banking procedure, I will get to understand what is the procedures followed in the bank when done manually. And based on that, I will go for automating, writing a program. I will fix the framework, fix the language. I start writing the code, those things are actually. So now, before, whenever a computer scientist or engineer comes to automate the process, there should be a precise definition. I want to write a software for a banking transaction. First, I should understand the banking transaction very clearly, and all the banking procedures should be well defined. There should not be ambiguity. So those things and all will create. But unfortunately, there is no precise definition for a learning. Everyone has having a different perspective. As we saw, psychologist is having a different perspective, and engineers are having different perspective, teachers are having a different perspective. Then how could we learn made the possible? So now, when there is no procedure, okay, how we learn? We simulate the brain. We actually imitate the brain. What is the thing? For example, if we don't have any clear-cut procedure, then how we learn, human beings learn with the help of our brain neural networks. There are many things getting fired, activated, all this drama happen. So how to simulate the brain? That is very difficult concept actually. So as an alternate approach, what we do this, can we settle for programs that imitate cognitive skill? What do you mean by cognitive skills? The activities that imitate the core functions of the brain. To read, to write, to hear, see, touch. I touch on surface and feel that it is very soft. I see certain objects and identify they are the fruits. I identify, I hear certain music and say that the music is soothing to my heart, like that. So these are the cognitive, to read, write, hear, see, touch, remember, reasoning, or the basic cognitive skills actually. So for example, how do the rats learn actually? When the first rat will not eat any food without any testing. First it will start slowly eating a small amount of food. Then after that, it will compare with its past experience. So for example, it has eaten certain thing and it will, oh, this is something like which I took 2 days back in another house and there I got fainted. There is something uneasy feeling. And if there is anything fishy, it won't eat it out. So if the food produces an ill effect, the novel food will often be associated with the illness and subsequently the rats will not eat. Clearly, there is a learning mechanism. The way they learn is based on their experience. That is the thing. Even learning a language. How do we learn a language? How do we learn your mother tongue? Based on the practice only. First thing, for example, this type of learning is called technically reinforcement learning. And for example, the small child starts opening the mouth, ta, pa, something like it. When it says ta, the other neighbor, oh, this is ta, ta, like that, they will coin the words and try to help the thing. Like that, based on the experience. First, we learned single letter word, then double letter word, sentences, like that actually. We didn't undergo any 45 days course in in mother tongue actually. Like that, there are many things which are done by the experience actually. So in the rat example, the task is to identify the food which does not harm the rat. In the learning the language example, the task is to learn and to reply the question. In the same way, there is another thing. I want a computer program to identify a teacup. I can give a rule like it. It has a handle, it is open, it can contain some liquid, something I can make it out actually. Then if there is a big barrel, that also satisfies all this condition. Then big barrel, so based on that I have to define it. So it is learning from the example and the counter example, which is not a cup, which is a cup. Like that it goes on and actually. So like that, one thing is clear is, now coming to the based on the thing, learning happens through experience. That experience, technically, we call that as a data set. So a machine learning is a computer program. It's a very fine definition given by Tom Mitchell in 1997, which this is the first formal textbook in machine learning actually. So a computer programming, a learning model. So machine learning algorithm or machine learning model or a computer program are all synonyms that learns from experience. For every learning, there should be a task. What is the task of the rat here actually? What is in the rat example, task has to identify whether this food is going to do harm or not. That is, the task is to classify, to label it as a good or bad. And in the learning language, what is the task? If somebody is asking what is the purpose of the chatbot, if somebody is going to ask a question, I have to respond. That is the purpose of the chatbot actually. The task is to learn and reply the question. So that should be clear, task should be there. And after that, we have, whenever we teach the students, when the student has learned something, we conduct an examination. So to know the level of their learning, performance of the learning, that is called performance. So, for example, the rat example, how do you rate the performance of a rat if it has smelled 4 food items and correctly identify the poison food and non-poison food correctly? Then the ratio here is so that the food is harmless, but the rat. So, if we can measure the learning of the rat as 3 over 4. So, if it has identified correctly 3 food items of the total 4, then the performance is 3 by 4. Something like if there are 4 single word questions and student has answered 3 questions correctly, what is his mark? 3 over 4. That's all. The same thing. So 3 things are important for in the machine learning model. One is experience. From the experience only it is going to do some learning. Okay. Then T. T is the task. For every algorithm, there will be a clear-cut task. And what is this P? And when the algorithm performs, we have to measure how good it has performed. That is the thing. And performance should increase based on E increases. That is based if there is a doctor or a teacher or an advocate or a chartered accountant, and as days go by, if he is an experienced person, his performance rate will be highly successful. If he is a doctor with 35 years of experience, and if he does an operation, that will be highly successful. Compare this doctor with the doctor who is going to perform a first operation. Then he will be shaky and other things. Sometimes it may be a flop, it may be a successful, all these things actually. So for example, this is one ETP framework. So any machine learning problem or any subjective problem can be put like this. Task, robot driving learning program. Task T. What is the thing? Driving on a 4-lane highway with vision sensors. No driver is going to be there, but there are sensors which capture the vision will be there. And performance measure of that average distance traveled before an error, before hitting the median or something. Training experience, a sequence of images and steering commands recorded while observing a human driver. When the human driver is driving a vehicle, we have recorded all these videos, and based on that, it is going to, learn it out actually. So this is the thing. So machine learning is just a computer programming, and this is the thing. And basic 3 models of programming, machine learning models are there. Regression, like we have seeing, hearing, touching, reading, writing, speaking, remembering. We are having just 3 alone. Regression, classification, clustering. Regression means to predict the doctor's consulting fee. That is a highly subjective problem. We can apply a machine learning. And how the schools are charging the fee. How the colleges are charging a fee. There is no formula depending upon the amenities. How does the cost of an apartment depending? Now this apartment is a gated community. It is having a swimming pool. It is having a library. It is having a community hall. Like that. The people will say that. So based on that, the rate will increase. How much to increase? Nobody knows. So predict the value of a land, predict the value of the house, predict the consultation fee for the doctor. These are all called regression. Like we touch and learn, we see and learn, we eat and learn. We eat something, oh, this is very good sweet, I like it. Something, that is the learning component actually. And after that, classification. What is classification? I go to a market, I buy vegetables and put all the vegetables into one same bag. I come home and my wife is asking to segregate and put it in the refrigerator. So I have to segregate, label it. Take, this is apple, this is orange, this is like that actually. So classification, for example, if I have a machine learning problem, given the symptoms, I have to identify whether the patient is suffering with cancer, yes or no. So I am classifying the patients based on the symptoms, yes or no. Yes, this patient is having cancer. No, this patient is not having cancer. I am labeling. That is called a classification. In the same way, clustering. In the classification, you would have seen the vegetables earlier. You know which is potato, which is tomato, which is apple. But in the clustering, you have not seen that vegetable earlier. You have to segregate it. You have to make them into group. For example, I have a bunch of vegetables which you have not seen at all. Okay, then you can have it. Oh, based on the color, I can separate. Or based on the weight, I can separate. Or based on the taste, I can separate. It is in your hand to segregate it. So these are the three major learning models for deep learning for everything. Same thing will come again and again and again and again. That's all actually. Regression means prediction. How the chatbot makes out? Chatbot based on if you give the n words, it is going to predict n plus 1 label based on the transformer model, chat-based chatbots, that is Llama, those things and all. OpenAI chatbots, it is going to predict. In the same way, classification. How do you make the things classification? You have the same vegetables put together based on potato or tomato, apple, you are going to classify. That is called the classification. So these are the three machine learning paradigms which we'll be using now. Now we go to the regression part and see the mathematics of it. Then we go to the classification component and see what is the concept behind it. Then the clustering actually. Now this is the full picture of your machine learning. I hope you are able to see this model, this chart diagram. I think machine learning, supervised learning, unsupervised learning, reinforce. Are you able to see this chart clearly? Are you able to see this chart clearly? Can I get a response? Hello? Can I get a response? Hello? Are you able to see the chart? Can I get a response? Am I audible or not? Hello, am I audible or not?
Sir, very clear, sir. Now we are hearing very clear voice.
Very good, very good, very good. Now, this chart, I'll go to the... so, machine learning branches...
Actually, the problem is rectified, sir.
Very good, very good, very good. So now we are having supervised learning, unsupervised learning, reinforcement learning. Now, supervised learning means the data set where the output will be there itself. I will show all these things actually. Then unsupervised learning, reinforcement. We'll try to cover one or two models. See the classification, clustering, regression, and dimensionality reduction. These are model-based reinforcement learning, all these things actually. So at least 2 or 3 models, depending upon the time permission for another 1 hour, I think it's time 4 o'clock, and I'll make it out actually. So now coming back to the, after this ML, I'll make it regression. What is the paradigm of regression we get into? Because we can understand the mathematical concepts only if we know what it actually. Only for that I'm giving an introduction. That I will be converging into the mathematical concept then in that way. So simple linear regression I'm going to take now. Paradigm of regression. So what is actually regression? What is learning? Those things. So far what we have covered, machine learning models are amenable for subjective problem. That is one clear. And what is machine learning algorithm? Machine learning algorithm is having 3 components. ETP, experience. For every problem, there should be experience. There should be a data set. That is, if you want to predict the price of a house in a particular locality, what is required? You have to take all the houses which are sold for the past 10 or 15 years with all the characters, features. You have to prepare a table that is called experience data set. And for any model, we can measure the performance of that model. So now, regression. So now land price fixing problem. So first thing, land price fixing problem, first check whether it is subjective or not. It is subjective. In any place across the globe, land price, the price of a land is calculated by a single formula. It will go up, it will come down like a stock price and other things actually. So it is a highly subjective problem. I want to solve this problem using machine learning. So how to solve this problem? So to fix a price for a, thing, all this thing. So now, first thing, I have to make ETP. We have discussed it. experience, task, performance should be made ready. Only then I can go with the algorithm. Experience has to be made ready. So now what I can do, I have to create a data set. I didn't even at present in Indian AI is suffering from the data set. Most of the data sets are downloaded by the students and applied. That the downloaded data sets may not fit well for the Indian circumstances. So only for that data AI, the government of India is launching a thing. For many of the problem, we have to create our own data set. What is data set? For identify a few factors on which the price of the land depends. Some factors may be length of the land, breadth of the land, locality, whether it is residential area or a commercial area, distance between the land and the nearest hospital, distance between the land and the nearest, all these things actually. And these are the factors which are decided by the user. We call these factors as futures or parameters. More factors you capture, your learning will be good. If you are able to capture one or two, learning may not be that good. So one can have any number of factors, but the factors have to be independent of each other. And collect the information of the above factors for each of the land in the locality and get to know the prices quoted by the respective owner. Then how many lands I have to make it? As many things. Take the how many lands are sold for the past. So like that it will be, I will be creating a data set. And see the thing, the last column is the output value. Because here the task is to predict the price. I am having 1,000 data with all this information and how much price it is sold. It was sold for 2 lakhs of rupees. It was sold for 4.5 lakhs of rupees, like that. So if a data set has the output component, I'll call that as a supervised learning. Because after prediction, I can get to know whether my answer is correct or not. Like the teacher, but the student solves a problem and goes to a teacher to check whether his solving is correct or not. That's supervised thing actually. So this is the data set actually. Then like that everything now residential, RRC, residential or commercial, I have made it. I have to change that into numbers. Everything should be converted into numbers. So for example, what is the task? Given the information about all the input attributes of the land to compute the price of the land. So I am having, based on this experience, I want to compute the price of my own land. I am having a land of length 29 feet, breadth 24 feet, and the locality is 0, that is residential. DH means distance from the hospital is 1 feet, and distance from the school is 2 feet. What is the price of the land? So this thing I can express as a tuple, 29, 24, 0, 1, 2, what is the price of it? And this information will not be in this data set. If it is in the data set, I can see the last column and get to know it actually. So how to do it? So for that procedure, what we do, we are going to propose one equation. This is called hypothesis. The max drama comes into the picture. Without max, nothing can be there here. So for example, you assume that the price is going to be based on all the factors. But how much importance for the length? How much importance for the breadth? How much importance for the area? How much importance for the distance from the hospital? Nobody knows. That importance is put in the form of a parameter called W1. So I am going to give this length of the house W1 percentage of importance, breadth W2 percentage of the importance. W4 is the importance given to the distance between my house and the hospital, like that actually. And this is going to be based on this. So then here actually how to understand what is actually learning, to compute the level of importance, how much importance you are going to give, to compute the values of W1, W2, W3, W4, W5, W0 are your learning. The machine learning model is going to do only this work. So for example, you assume by some procedure you have calculated. We'll go to the mathematical part and the next slide. So learning process called regression is considering all the values of the training data. The data set is going to be called as the training data. We compute the values of the unknowns. Here small l is known, b is known. See here, see the data set, locality, small l, breadth, dh, everything is known to you. Which is not known to you? This w is the stranger you brought inside. So W1, W2, W3, W4, W5, W0, you don't know anything in that. So considering all the values of the training data, we compute the values of the unknowns. That computing the weight is called the learning here. Can you get the point? See, for example, human being eat and learn something. Oh, what I ate is a sweet. Human being touch something and say, hey, this is a rough surface. That is the learning. Here, how does the algorithm is going to learn? Algorithm is going to learn by computing the W's. Oh, this, whether if I go to an algorithm and ask what I have learned, it will show a W1, W2, W3. For example, this ChatGPT, OpenAI ChatGPT, it is going to predict the next word. It is going to predict an answer for your question. So it comes under technical regression. So how many parameters it is going to have? 17 billion parameters. Here we are having just 6 parameters. Can you get the point? Only the scale up, it is getting scaled up. That's the only difference. And the data set, the whole internet is a data set for it. It is everything structured in a formal way, and then model works out actually. So this is the regression now. So now if I know, for example, somehow I have calculated, we'll go to the next slide, how to calculate it. W0 is equal 0, W1 is equal 0.2, like that actually. Then how will you predict the price of made use? That means what? W0 is 0, W1 0.2, W2 0.1, W3 0.01 means that level of importance that can be given to that particular future. Because the price of the land depends upon many factors. Okay, which factor you want to have prioritized? Oh, this is a very important factor. This is less important factor. If you ask the opinion for 1,000 people, they will give 1,000 ideas. So only for that to know the importance the society is going to give that for the particular future, I am getting the data set. The society's mind is captured in this. Mr. A sold this house for this 2 lakhs rupees where the input is like this. Mr. B sold this house 4.5 lakhs where the input is like this. Like that, different. So the whole society's opinion is embedded in this data set. Based on that opinion, model is going to calculate the weights actually. So the learning, so when you say that learning, they are calculating the weights, that's all. That is OpenAI, ChatGPT, they are all calculating only the weights actually. Can you get the point? So now, once the weights are calculated, how to predict out what is my land actually? I have to price the, compute the price for my input. 29 length, 24 breadth, 0 locality is residential, 1 feet distance from the hospital, 2 feet distance from the school. I'm going to substitute all these things. L value, B value, capital L, DH, and the substitute and say that my price is going to be 8.21. Like that actually. Now here, the error will be there actually. See, for example, I have the third part I am making it. So now what is the error here actually for the first item? Calculate the price one. So using this weights, you just calculate using your formula whether you are getting 2 or not. For example, we have calculated using our, how to calculate it, just I am making it. Now you just assume that I have calculated, that's all. That how to calculate this W1, W0 to W5, I'll tell you. That is the main core of the discussion, mathematical content we are going to discuss. Assume that I am just explaining after calculating how we are going to predict this thing. So just you will be substituting the values in that. Okay, very good, fine. Now, how the learning comes? So based on the weight for every row, using your weight you calculate. So for example, what 10, 20, 1, 10, 30 is there. So you are having a very clear-cut formula here. What is the prediction? 0.2 into L, plus 0.1 into B, plus 0.01 into capital L, plus 0.001 into DH, plus 0.002 into DS, those things. You calculate all these input values, small l, small b, capital L, those things actually. So when you, for the first item, it is 10, 20, 1, 10, 30. Please see the thing, data set 10, 20, 1, 10, 30. So when I substitute all these things, I am getting what is the thing I am having here. See here, I am calculating, it is the price is coming as 4.08. But whereas the real it was sold for 2 lakhs of rupees. So there is a error here. So for based on my weight calculation, every row in the data set will have some error. So 2.08 is the difference between the predicted value and the actual value. Actual value is 2 lakhs rupees. Predicted value is 4.08. So this is called error. Sometimes the error may be positive, negative. Here it is 4.08 minus 2. Now I can also check the difference between the predicted and the actual value is the main thing. I can also do the subtraction 2 minus 4.08. Not necessarily that it has to be 4.08 minus 2. So this drama happens. Only to get rid of this, we take the square of it. So finally, 4.37 is the error generated by the first row. Like that, we calculate the error in all the rows of the data set. In all the rows of the data set. Am I correct or not? So then you take the average of it. So that is called thing. The cap is called T is the superfix T is for the item number. This item number, first item, second item, third item, serial number actually. Cap is the predicted one, predicted using the model. And PR, just PR is the price which is in the last column. This is the price actually. So now we will make it out. This is the thing. If P is equal to 0 means what? This is based on error calculation. If P is equal to 0 means what? There is no error in any of the data, any of the rows. So our learning model has learned perfectly. If P is high, what you have to do? You have to change the hypothesis. That's all. So now we will come to that conclusion now actually. So now the whole data set can be written in the algebraic form. XTRT. R stands for the output. That is a notion followed standard. XT is the data set. I mean, length, breadth, locality, DH, DS, they are all what? The first tuple X1, X2 and so on. It is like a d-dimensional vector. So X is equal to X1, X2, and so on, XD. This is an element of RD. Because everything is a real number actually. So X is a d-dimensional vector, R is in R. Here Xi's are the input attributes, features, parameter, all are synonyms. So X is a tuple, D tuple here. X is the input variable, R is the output variable, and XT is the item number. So first item, how did I express this? First item in this data set I can express like this: 10, 20, 1, 10, 30. So small x1, first thing instead of L, I call that as x1, like that actually. So this is the data set can be expressed like this, and task is what? To find the relationship between x1, x2, xd. This is the thing see here, what is the thing? This is the relationship between the input attributes and the output. Output is the PR hat. So that relationship is brought by one linear equation, not necessarily linear equation, just for our understanding we are taking it actually. So this is the thing we are going to have it. So now performance measure. So performance measure, average of the square of the error, difference between the actual input and output made in each instance. This is the thing we are having here. So now this is called the paradigm of, this is the data set, sample data set. So first item x1 superfix 1, x2 superfix 1, x3 superfix 1, r superfix 1. This is the first row, in features. What are the features? x1, x2, x3 and so on. What is the output? R is the output actually. So this is the thing. So the process of learning, regression, what is the thing? We are calculating the weights, nothing other than that actually. Now we go for how to calculate those weights, that is the problem here. So now simple linear regression, I am taking simple linear regression. So this model we are going to make it out very clearly. Here all the mathematics will come into the picture. So problem description, now we'll be slightly mathematical, slightly, it's not, it is under, what is the thing we have expressed. So data set is going to be represented by capital X, and every row is going to be expressed as a D tuple, X1, X2 and so on, XD, and is an element of RT, set of real numbers R cross R, like R square is equal to R cross a Cartesian product, like that actually. X is a d-dimensional vector, X is the input variable, XT superfix means what? The item number, row number, RT is the Tth output actually. So typical data set will look like anything. So what is the task in the regression? I have to write one equation combining this x1, x2 and so on to xd and r. Am I correct? Any doubts so far? Am I audible? Am I audible or not?
Yes, sir.
Yes, sir.
Very
Yes,
good,
sir.
very good. Now that and then let me check the pulse actually, that is the thing. So I will also get a feeling that audience are there, no issues. So now the task is to calculate so what we are getting into the mathematical concept behind the regression with different combination. That is the agenda now at present. So we have understood so far ML, why we require ML to solve the subjective problem, and what is actually ML means. It is calculating the weights. Okay. Now we have come to the stage how the for any ML, if you want to solve a problem using machine learning, we have to have three concepts, ETP. That also we saw with the example, experience, task and performance. Performance is we are calculating the performance of the model by the error it does, how much error it does, like that. So now this is the thing. Hypothesis means just proposing a relationship involving x1, 2. Sample hypothesis may be W1 x1, W2 x2, W3 x3 and so on, W0. And another hypothesis, this is for example second, I hope you are able to see my screen. Another hypothesis, why I should have degree 1 for x1 and degree 1 for x2 and so on. I can have degree 2 also for it, W1 x1 square plus W2 x2 square plus W3 x3 square and so on. So I can choose the hypothesis anyway. So now learning is to compute the values of the weights. For example, in our school days, what is the thing here? We are in the school days, what we would have done here is just I'll go to the thing. So now we will be given one. Just I'll. So for example, in the school days, what you would have done here, X values will be there 1, 4, 5, 6, 7 and 7. Then after that, Y value will be given. Y value will be 8, 11, something like 12 and 4 and 5. What we will be doing, what we will be drawing one graph. We will be pointing this, assume that it is 8, 1, 8. 1, 8 will be here. I will point it. And 4, 11. 4, 11 will be here. Like that, I will draw the point. 7, 5 will be somewhere here. I will be trying to connect the points. Am I correct or not? Something like it. Am I correct or not? This is now here for 4 data set we are having it. Now, I mean, from the data we are drawing a graph. Am I correct or not? But this data, if it is 4 or 5, I'll put it another way. 1 minute. So for example, given a data, I am going to capture the function that is called the machine learning. That is the thing we are going to. And we will be drawing in the school level just the graph. What is the equation of the graph? Nobody knows. What is the equation of that? Knowing the equation of the graph, that is, it is an opposite procedure for it. For example, if I have f of x is equal to x square. Now I can have in a data set like this. I can have it 1, 2, 3 like that. I can have it. Now I can have x square for that. Y value, f of x value is 1. This is 4. This is 9. Am I correct or not? Now in the school we went in this approach. In the machine learning model we are going in this approach. That is the thing. You are given a data set. You have to predict this function. This function prediction is the task. It can be x square. If f of x is equal to x square is given, I can draw the data. Okay, but now the function I don't know. So now I am given the data set like this. From this I am going to predict the reversal procedure, what you learned in the school, drawing a graph, given a function, drawing a graph. Now given a data, you have to compute the function. For that only we are doing all these dramas actually. For example, this is the thing which we are, I am making a, 1 minute. What was the slide I was making? 1 minute. Paradigm regression, simple linear regression. Yeah, this is the thing. So this is the thing which you are going to do. So you are given a data set. I have to compute the function which governs all this thing. So for that, I am making a guess. This proposition, this hypothesis is just a guess. How does the doctor makes a guess while treating us? He gets all the inputs. Oh, it might be that disease. Okay, let me give a tablet for 3 days. Okay, after 3 days you just come back. Then if the patient feels well, okay, that's good. His guessing has become correct. If after 3 days the problem still persists, the doctor will give some other more. Will change the tablets, all this thing. Same thing, by like changing the tablets, I am going to change the hypothesis actually. Different hypothesis of that. Now, so to compute the values of the weight. So if I am making a procedure W1x1 plus W2x2, this is, sir, how can they be connected linearly? Why not be non-linear? Everything is possible. I don't know anything about the data set, just the numbers are there. From the numbers, how can I predict? So I am just first testing with linear. So G of xt is the value, the same error and other things, I'll make it out. So, learning model, what is this, error? Predicted RT, R means what? The output, real value. G of xt means what? In the hypothesis, I have to find out the values and substitute, and this is the thing. For example, G of x is equal to, assume that I have found out the values of W1, W2, W3 and so on, W0. Okay, G of 4 will be what? This x1, x2 are in the data set. We know that actually, which is unknown. W1, W2 is unknown actually. So now, if you substitute, I will get an equation, that's all. So now, what is that value? After having found out, there will be some value for it. So that is called the predicted value, G of xt minus RT. Xt is the input given in the data set. RT is the output given in the data set for the tth row. So n is the total number of samples in the data set actually. So now that is the error actually. So now in the learning, what is the thing? Some optimization is going to happen. To calculate the mathematical problem is to calculate the weights W0, W1, W2 and so on, Wn based on the data set X such that this is minimum. When a student prepares for an examination, he is given the syllabus, the teaching material, what the teachers have shared with the PPT slides, everything, they will make it. And the pattern of question paper, duration of the question paper, all the things are given. He has to prepare in such a way that his mark should be maximum. Now, he has to prevent this. Here, we have to calculate because certain values may fit for the first row. The same values may throw some error for the second row. It may be a problem in the third row, like the 10,000 rows are there. How to satisfy all the 10,000 people? Because all those 10,000 data points are collected from the society. I should have a solution which is suitable for all the 10,000. If it is 1 or 2 lines, for example, I'll go like this actually. Say for example, if there is the data set is 1, 4, 1, 2, 4. Then another data set is 7, 6, 5, like that actually. Then what I can do, first this is what? X1, W1 into 1 plus 2W2. I am making it as an expression. 2W2 plus 4W3. Am I correct? 4W3. Another thing is 7W1 plus 6W2 plus 5W3. And assume that there is another one thing. So 8, 4, 2. I can have, so 3 variables I have to calculate, 3 equations, and I can solve it. But unfortunately, your data set is not going to have 3 rows only. It will have plenty of rows. So the normal system of equation method may not suit the purpose. So for that reason, what is the thing we are going to do here is we have to, so the problem is clear. We have to calculate the values of W0 to Wn based on the data set X such that this is minimum. So how to make it out? So the square of the difference can be as the distance between the points, whatever it is. This is the thing. Now, in the geometric, I'll go geometric sense also. If you write a linear equation, I can have one that the dots are the data points. If there are two tuples, I am expressing in the two-dimensional plane. If there are 20 tuples, we have to visualize this in the 20-dimensional space actually. So now the dots are there. I can, if you, what is the geometrical interpretation of this linear equation? It is going to stand for the straight line. Y is equal to mx plus c, that is in two dimension. Y is equal to the equation of the plane is a1 x1 plus a2 x2 plus a3 x3. It's a three-dimensional plane like that. So I can have many things. So for example, I am having this drawn line is the proposal hypothesis, and this data points are there. What is this red arrow? This is the difference between the actual value. Actual value is the green square, and this point. This is the actual difference. This is called error. Error may be that side or maybe this side actually. So like that. So now I have to calculate this error. So for that type, if we are just segregating, if your regression hypothesis is going to be of degree 1 in W's. W's are the unknowns. The conventional setup X are unknown in the mathematical domain. But here X1s are known, they are in the data set. W's are the unknowns actually. So they are, the degree of W's are what? 1. So it is called linear. Why it is called simple? If D is equal to 1, dimension is 1. So I call that as simple. Simple linear regression. Multiple linear regression means what? Dimensions are more than 2. So for example, see this multiple linear regression 2 equation, g of x is equal to one thing and w0 plus w1 x1 square plus w2 x2 square, because this is another hypothesis. If the first hypothesis is throwing more error, we have to try with the second hypothesis. So this is linear in W's. In both the things, linear in W's. What is the non-linear in W? For example, simple non-linear regression. Simple means what? Only one input data, dimension is 1. So g of x is equal to w0 e power w1x. Multiple non-linear regression, w1x plus w2 plus x, where d is greater. Like that, there are many things actually. So now coming to the problem. So now what is the thing? To minimize error. Error is subject to, we denote the notation. G is the hypothesis which we propose. Error of created by the hypothesis G given the data set X. E, G slash X means what? Like your conditional probability of A given B. Like that you can read this. Error generated by the hypothesis G with respect to X. What is the thing? And compute the weights of it. E is a function of D unknowns parameter. So it's a D-dimensional set. So now the problem comes to maxima minima. Am I correct? Given a function f of x, to find the value of x such that f of x is minimum. Your 12th class basic calculus mathematics. Nothing other than that in the machine learning. So now, if you want to find out the mathematics of minimum, you have to draw the curve like it. We have read that local minimum, global minimum, and when the f of x attains a minimum at a point, if the first derivative is 0 and second derivative is positive, or the other way, maximum, we need not worry about the maximum. We want minimum. The f of x function is this one. What is the f of x function here? This e of g, that is error. E stands for error. Error of g given x is equal to, we are having this rt minus g of xt. It is an expression involving w's. Sir, there is no w in that. Why are you saying w? R is the output value given. G of x is the w. G of x you are defining like this. G of x is equal to w1 x1 plus w2 x2 and so on actually. So we are having those things and all. So we have to calculate how to calculate. Now, if it is a function of single variable, I have the formula to find the minimum. If it is a function of two variables, I have the formula, that second derivative formula and other things. Am I correct or not? But unfortunately, your data set is going to have how many dimensions? More than 2, there won't be any machine learning problem with just 2 features or something actually. Can you? So that's what I'm telling. ChatGPT, OpenAI, ChatGPT is having 17 billion parameters. If you plot a point, you have to plot in a space of 17 billion parameter. Then you'll ask, how did they do that? That the representation, I can have it in algebra. I can express the combination of this linear combination of that actually. So now we find out what we have a difficulty in the real time problem. That if it is 2 dimension, 1 dimension, confined to the mathematics textbook of your 11th class or 12th class or first year BTech, no issues actually. But unfortunately, this is of heavy dimension. There is no formula even now actually. So what to do now? The one basic thing here it is given here is the error function is going to be a bundle of squares actually. Am I correct or not? That is, why this E of G given X is some square plus another square plus another square plus another square. And if it is a bundle of square, for example, that is something like it, like summation I is equal to 1 to n, something square plus something square plus something square. And if n is equal to, it is going to be a parabola. If n is equal to 2, it will be like a bowl, 3 dimension, like that actually. And we have in this type of figure, mathematics is having a one strong result. Minimum point is the point where the function takes the minimum, and there is only one minimum point. Whereas here, how many minimum points are there? Local minimum, global minimum. Global minimum is what? We have to predict the function, minimum value of the function, lowest value, that is called the global minimum. Local minimum, for example, at this point it is local, global, and local, and this is global because this is the smallest of all the values of it. This is local minimum. Can you get the point? So now these type of figure will have only one minimum point, that is global minimum, that is local minimum. That makes the situation very easy for our real-time implementation. So minimum point is the point where the function takes the minimum value. Sum square function, this error function is what? It is a bundle of square. Are you able to follow here? It is I want to have objective function, error function is just sum square plus another square plus another square, another square. So in that sense, what is the thing here? We call that as sum squares. Sum of the squares has only one minimum point. That point is local minimum. Okay, how to identify the point? At that point, first derivative will be 0. So we solve the equations obtained by equating the first derivative to 0 and obtain the stationary points, and that point itself will be big. If there are 4 or 5 points where the derivative becomes 0, we'll do this test for the second dimension, whether the second derivative is positive or negative. If it is negative, it is maximum, minimum, something like it. Like this, we have it. Am I correct or not? Here, we are going to have only one point. And that point is going to be minimum. So it is enough if we find out the equation of the tangent at that particular point and equate that tangent to 0 and find out the points. So now coming back, our error function is the sum of square. There will be only one minimum point. That minimum point I am going to call that as W0, W1, W2 and WD. Takes the global minimum. First derivative becomes 0. To identify the point where the derivative becomes 0. So if I want to know the points where the derivative becomes 0, what do I do in mathematics? Just find out the derivative, equate that to 0, and calculate the values. Am I correct? Like this, the algorithm has come. So input is the data set and hypothesis. Hypothesis, data set go together. If you change the hypothesis, the drama will change. So what is the E is an equation in W0, W1 and WD. And for I is equal to 0 to D for each dimension, for each vector, you have to, for example, I is equal to 0 means I will be calculating W0. So dou E by dou dy, for everything I will be getting D plus 1 equations and D plus 1 unknowns. And we have to solve it and do it. Am I correct or not? So now this is the mathematics behind it. Of course, sometimes, for example, this will be very tedious if the number of 17 billion parameters, I can't solve the system of equation to find out 17 billion unknowns. So how many equations I will be having? 17 billion unknowns I will be having. This is very tedious. I can't go with that actually. So now one example, one illustration for it. So now for example, for some data, so for example, you just to compute DOE, we have calculated the partial derivative of E with respect to W naught and simplify. Finally, we are getting this formula. W naught is equal to, what is this? RT, the sum the values of R minus W1. W1 is this actually. Hope you understand. For example, I will go to this thing. For example, xt square means what? X value, you have to square it out. RT square, xt square, RT square, you have to square X square, R square and then calculate it. So the formula for W1 is what? Using this formula, I have calculated X square. X is 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, R square. Like that I calculate XR. So I just substitute based on the mathematical derivation. What do I have done here? I have calculated dou E by dou W. I have to find out two unknowns here. So the algorithm tells me that dou E by dou W naught is equal 0, one equation. Another equation is dou E by dou W1 if it is 2 dimension. So for example, I have taken only 2 dimension. I will be calculating it. I will be simplifying it. I am getting the formula. Okay, very good. This is called simple linear regression. But this drama cannot be applied for all the things. Am I correct or not? Then what to do for it? So now, so now we have got to predict the output. We have got W1, W2, and we have G of X is equal to, we have calculated the weight. So now this algorithm has learned. This algorithm has learned the values. It is computing. What does that algorithm does? Algorithm does to compute W0, W1, and W2. Can you get the point? So that is the way it has done. Very good, fine. Now we want to calculate the errors. In each one, you apply this formula. What is the difference between G of X and R square? R square is 1 here. G of X is 0.6. G of X is calculated using this value. And finally, error comes to 0.044. The total sum of the error, G of X minus R whole square divided by N. The average error is 0.044. Like that it goes on. This is the thing we do here is. Very good. Now, if there's to choose the, for example, we can propose it, if you want to still decrease that, I want 0 error, mean change the hypothesis. We don't know whether the data is depicting 2-dimensional function or whether the data is depicting for a 3-dimensional function, whether it is depicting 10-dimensional, we don't know. Just to make a guess of it. And if it is linear, this may work out. For example, if it is a nonlinear function, if you try with a linear hypothesis, then it will throw more errors. So by a trial and error, we have to make it. So now performance, the training need not be chosen. So like that, it goes off. So this is how to make it out, those things. What is the usual thing is, the data set, they divided. If you have 1000 data points, 80 points for training. Divide the data set X into 2 parts, training data set, validation data set. Usually 75% of the total data points form the training data set. That is, it is something like it. I am having 1000 questions, or rather 100 questions, I am teaching a course. 80 questions, of the 1000 questions, 80 questions, I will be explaining on the board with all the problems. 20 questions, I will give it for examination. And the question which is going to come from the university is called test data. 80 problems, I am with 80 problems, I am solving on the blackboard and training the student. Based on the training, I expect the remaining 20 problems, they have to do it. That is called validation, whether I have taught correctly or not. If the students are able to solve the problem correctly, then that my training is there. What is the test data? Test data comes from unknown source. That is called, this is the thing. Now, coming back to the thing, the solving the equation may not be a good idea. So now what is the thing? Now very pakka linear algebra model here. For example, just see here. I will show the working here. So now, type of regression. First, whenever we want to solve a problem, we have to choose the type of regression. Simple linear regression, multiple linear regression, polynomial. That is the thing. For example, simple linear expression means what? I can have a hypothesis like it. Sir, W0 plus W1 into 1 over X is also simple only. It is also linear only because the degrees of W's are 1. Don't forget, we are not focusing on the X, we are focusing on the weights. Weight is the unknown we have to calculate. Multiple linear regression, this is one hypothesis. We have to propose a hypothesis. Same thing like the doctor does. So first thing, what is the method which we followed in the first thing? You take the partial derivative of E with respect to the W's and equate to 0 and solve the equation. But certain times it may not be that much easy. So for that reason, what we have got it here, because the real-time data set, if your experience is more, there will be many rows in the data set. Can you get the point? Sir, calculation is very difficult. I will have the data set with the 3 rows alone, nothing will be there. That prediction will not be anywhere correct. 100% guarantee we can say that it is useless prediction. So we have to have a more data set. How this ChatGPT gives a response for all our questions, because the whole internet is its data set. It has learned, it has calculated the values of W's, parameter, considering all the content. That is the power of it. If you ask a doubt in maximum minima, how to make it out, or if you ask the algorithm for the regression model of thing, it will immediately prompt it, because the data set, many people have put their content in the internet. It has used that as a data set. So propose a hypothesis, like that it goes on. So first stage is choose the type of regression. If you want to, sir, this data set, I think that it will be linear, then use the linear proposal. If it is going, sir, it is going to be multiple variables, not single variable. Definitely it has to be. Okay, then you use for multiple variable. Okay. If it is non-linear also, you can make it. So first thing is, bluntly you propose one hypothesis. Choose the type of regression, propose a hypothesis. If this hypothesis is going to throw more error, we are going to change it. How the doctor makes a guess based on the symptoms. The same thing. Then compute the error function, or you can call by different names, and design the formula to compute the values of weights. So we have to calculate how to calculate the weights of it. This particular part, stage 4, is called ML model, ML algorithm, or ML program, where the model is trained with the data set. I am giving first row of the data set. Model comes to some conclusion. Oh, this is like it. Then second row is given. Third row is given. Fourth row is given. Based on all this thing, we are going to make it out. Compute the performance of the model with the validation data, actually. If the performance is satisfactory, then start predicting the output for the test data. If it is not, then take the next hypothesis. If the performance is not satisfactory, what to do? Like the doctor's thinking procedure, choose a different hypothesis and do that. It's going to be a trial and error game and never-ending game also. And we cannot predict 100% accuracy. So, for example, what are the components that may affect the performance? Choice of the data set. Your data set may not be reflecting the society's mood. The clerk would have done a mistake. Instead of 5, he would have written 25, something like it. Size of the data set. More you have the size of the data set, you will have the prediction. Size of the validation. That is usually, so validation data means 20 problems. I told you, 80 problems you teach in the class. 20 problems, you conduct a test for them. The size of the validation data should also be more, and number of input parameters. For example, in the land price fixing problem, we are having distance from the school, distance from the hospital, distance from main locality, like that we have it. That's a pure trial and error approach. Now coming back to the thing, now come back. So now, for example, now we are going to see certain little bit linear algebra, and this method is called normal equation method, actually. So, for example, polynomial regression, if you want for a polynomial regression, is a particular case of multiple linear regression. For example, number of input variables 1, degree of the polynomial is 1, degree of the polynomial is 2, like that, the same basic definitions and other things. Now, two input variable, degree of polynomial 1, this is more, W5 x2 square, like that. For example, this is the equation. For example, W0 plus W1 x1 plus W2 x2 plus W3 x1 x2, it is a polynomial in two variables x1 comma x2 of degree 2. Am I correct? And don't, for example, W4 may be 0 also, W3 may be 0 also till the degree, I mean, highest component is W5. So now, just make it out. We are going to express the data set as one matrix itself. For example, we'll go to the illustration and come back. After that, we'll make it out actually. For example, see here, I'm going to make one very interesting. I'll show the working also. I worked out in a paper and for you, I'm making it. So for example, the whole data set, 1, x1 square, because what is the hypothesis? W0. So usually this W0 will be considered as W0 x0. X0 is always 1. So now that is called bias technically. Let us not worry about it. So x0 value, I am making it. And then x1, the same value x1, x2, that is x superfix 1 means what? What is the value of this parameter? And x1 square, because the second equation is going to have w1 x1 square, wk xk. So this will be in the column actually. So for example, how many input variables are there? Only one input variables are there. Of one input variable, that input variable is k. I am giving a proposal hypothesis w0 plus w1 x1 plus and so on wk minus 1 x1 actually. So this D is called a design matrix, the whole data set. That is something like it. With that, what is the thing between this data set actually? What is the things? I'll make it out actually. I'll make it out. For example, there is a data set. I'll make this. This is one data set. For example, there is a data set. X, R. This is one dimension. This I am making it 4. Output is 10. Then you may say that, oh, x plus 4 is 10. Then after that 2, you will make it 3. So now the second data set tells you that it is going to be plus 1. So like this, the model will analyze all the 10,000 things. So 7, 14, 6, 12. Then based on 7, 14, 6, 12, don't say that 2x is equal to r. So like that, now this, like the data set is going to be, now I am going to predict this hypothesis w0 plus w1x plus w2x square. So for that I am going to calculate x square. X value is here. So w1 x square I have to make it out 16. This is 4. This is 14. This is 12. Like that I have to go on finding out. So for like that, if I have the hypothesis w3 x3, this is a x cube I have to calculate. Like that I am calculating all these things here. So I have taken a hypothesis w0 plus w1 x1 and so on to wk minus 1 k minus 1 x power k minus 1 plus wk xk. It is still linear in w's and this is called the design matrix. I create a data set. X value is given only one column. Then I calculate x square, x cube, like that actually. X superfix 1 means what? The data belonging to the first row, second row, like that actually. So like that. Now, then I have given this formula. So what is the error function here? I'll go to the working of this. I have just worked out here. I'll show it. I scanned it out for your purpose. I'll take this out now. Are you able to see my written thing? So what is the thing? Error here is yi value minus yi predict. That yi is usually the output. Now I am making it R matrix. Are you able to see my handwritten worksheet? Are you able to see my handwritten worksheet? This hat means it is the one predicted by it. Are you getting the point? So now I am expressing this error in the form of a norm. 1 by n for R is the output. This because it is the difference between the predicted and thing. D is what? D into W. If you expand the W, it is going to give the predicted value for each row. For example, D is what? This D is this matrix. DW means what? It will say that W naught plus W1 x1 plus W2 x1 square W2. First row will give the value of this value R1 value. Can you get the point? For example, if I take a product between the two matrices, what is the thing you will have here? It is of dimensionality is kept out. So now if I multiply D and W, what I will be getting here is R1 value I will be getting. Am I correct or not? Because that is the predicted R1 value. Real R1 value is in the data set. So can I express like this? Are you able to follow here? So R minus DW norm square. Then I express norm, I have to expand this norm square is R minus, that is I am expressing everything in terms of matrices. So and I am going to take the help of a linear algebra. Because what is our idea? That is MS mean minimum square error. I want to make the error function. I have squared it to get rid of the negative positive concept because I can also calculate yi minus yi cap or yi cap minus yi, whatever it is. So like that, this yi is the output value. Now I am expressing in my drama, output value represented by small r and D is the design matrix. That is, what are the terms in the hypothesis? I am going to make that column. What are the terms in the hypothesis? I am going to make that column. Am I correct or not? There is x1 column, x1 term, x. This one is what? Superfix 1 is the item number. So x1 square is what? So the square. That is why just now in the example I showed it to you actually. So this is the thing I am having. X square, 4 square, 2, 4, 7, 14, 6, 12 like that actually. So in the same way I am going to make it out. So this design, any doubt in the design matrix formulation? Design matrix? Any doubt in this design matrix formulation? And this R can be taken the last column in the data set. And this W is the one which you have to find out. Can you get the point? So now if you do this calculation, you multiply the matrix D and W, what will be the first entry? W naught plus W1 x1 plus W2 x1 square, like that actually. That is called what? Predicted value. So now going back to the thing, R minus DW transpose R minus. A transpose is A square, norm square actually. Now we apply the linear algebra concept. A minus B transpose is equal to A transpose minus B transpose. Okay, very good. R minus D transpose. Then I expand it. Normal distributive law apply, make it RTR. Hope you are able to follow. Minus R transpose DW minus W transpose D transpose R plus W transpose D transpose DW actually. So this is the thing. Here R transpose R is the output number. RT is just a dot product. Dot product like a vector dot product. It is the thing. And this is going to be a scalar only. And there is no W involved actually. Now what is the thing? And RT DW is a scalar 1 cross 1 size. Because RT is of size what? RT is, how many things that RT is, R is of size n cross 1. R transpose is 1 cross n. This D actually. This DW is of n cross 1. So now what is that? Why we are calculating this? This expansion, we have calculated this like this. Norm square is equal to this. Now I have calculated why there is a 2. These two values are same actually. When you calculate R transpose DW, W transpose D transpose R is going to be the same actually. Now I am putting it minus 2 WT D transpose R plus W transpose D transpose DW. So here RTR there is no W here. Why we are interested in constant with respect to Wy? Because what is the thing? If this error function is there, I have to find out the first derivative and equate to 0 as we did in the earlier case. Now we are not going to do in the equation way, we are going to do in the sense of linear algebra. So I want to differentiate dou by dou E r minus d minus whole square actually. So now what is the dou by dou W, sorry, this is dou by dou W. So I am going to make it. So first term is independent of W, so it will be 0. And here W transpose, it is only linear, power 1 only. So now what is the thing? What is the differentiation of it? 2 dtr. Am I correct? If I differentiate 2 dtr. And this one, there is a W transpose, W is there. So we will be getting a quadratic equation in W's actually. So I will be getting 2 in that sense, 2 dt dw. So sorry, this is the error, dou by dou W, because we have to differentiate with respect to the unknown actually. So finally, so now equate to 0, I am having minus 2 dtr plus 2 dt and other things. So dt d transpose dw is equal to d transpose r. W is equal to, I find out the inverse of it, d transpose d whole power minus 1 d transpose r. W is this actually. The same, this working only I have written here actually. So W is equal to dt. That is, in the design matrix, you take the transpose and multiply with the d and take the inverse of it, then multiply with d transpose, you will be getting it. So for an example, I have made it out here. So the same thing, one example, this is for this example, you can do this thing. And with the different data set, we can calculate with the different, we have run the experiments and we are making it actually. So now, this is the concept behind that mathematics actually. Now also here, sir, if this how many big it has to be. For example, if D is of 17 billion, even this becomes finding the inverse, everything is going to be difficult. Am I correct? That is a problem here also. Only thing is, with the matrix calculation, I can handle easily many number of equations. So then, what to do for it? Is there any other procedure for it? So first, everything is revolving around that. I mean, minimum value happens at the derivative, where the derivative becomes 0. And we are calculating, we are making the error function as the bundle of squares actually. So in that case, what is the thing you are going to get here is only one minimum. That minimum is global minimum. See how beautifully they have coined the objective function to make use of the real-time concept. Because if you calculate in a different way, we don't have any other methodology even now. Because it can't make it out. So now we have to understand. So like that, make it. So even I mean, for how many matrices I can calculate. So after a certain stage, this computing W also will become a problem for me because of the huge size of the matrix actually. So now for that reason, what is the thing we have got here is the last model we will make it out here is gradient descent. Just here. The same concept but only slightly here. Optimization, earlier we did the optimization. With optimization means what? We calculated the values of W in such a way that error is minimum. That is the optimization. Optimization is the method to find a solution in which you are interested. Here I am interested in finding the minimum value. Optimization using gradient descent concept. So what is gradient? We know descent will make it. Pseudocode, love those things and all. We'll make it. So now what are the things? Model, compute the error. You have to use the hypothesis, compute the error function, optimize the error function. Okay. Special method, there is a gradient. It is an iterative method. This calculation, for example, this is one-time method. See here, this algorithm tells you it is one time. That's all. The value what has come, it is that. We can't improve or manage all these things actually. Because you calculate descent matrix based on the hypothesis, you can calculate the D matrix. Based on the D matrix, you calculate this line number 6. dt, d transpose dt, r and other things. What is the first row? That will be W naught. Second row, W1. It will be a n cross 1 matrix. D plus 1 cross n1 matrix. How many unknowns will be there? How many values will be there? D plus 1. If it is of d dimensions, because we are having one constant term W naught also, usually referred to as bias actually. So now coming back to this concept, gradient descent. So now, first we will have a quick look. What is the gradient? It is just a partial derivative, that's all. And gradient of a function is the derivative of the function of several variables. Say, function of 3 variables, x, comma, y, comma, z. It has a close resemblance with the vector calculus. Gradient of f, del f, is equal to, the gradient operator is I dou by dou x plus j dou by dou y plus k dou by dou z. The surface S is defined by the scalar function. If I want to calculate, I will be getting a vector normal to the surface. F of xy is equal to 2x cube y plus zy square. Delta f is what? You have to calculate, differentiate partially with respect to x. F, that is dou f by dou x. That is 6x square I plus 2x cube plus 2zy plus y square k. That's all. It is called directional derivative because every component 6x square is the derivative of f in the direction of x-axis. 2x cube plus 2zy is the derivative in the direction of y-axis. Y square is the derivative in the direction of z-axis. So this is the normal thing which everyone knows, this thing. Now gradient descent. Usually when you have, this is the formula. I'm not going into the proof of the formula. We are going to use that formula. That is the formula expressed in the theory, how we can use for real-time application. Because only difference between the theory and the real-time application is, in the real-time application, it is scaling up. The number of parameter dimensions are very heavy. So we can't make it out normally. But we have a confidence, sir, in the theory it is possible. But in the real time, it throws many problem for us. So for that reason, we are going for different methodology. But this gradient descent is the very powerful method which is used in deep learning, even in the transformer model used in the large language models and other things. The simple idea. So with this, we'll wind up another 5 or 10 minutes. Sorry, I'm exceeding the time. Just bear with me for 5 minutes or 10 minutes more actually. So let f of xy be a function with parameters. One function. Here, instead of the function, there I am going to call that as an error function. And parameters are there. Here we call the parameters as x and y. There the parameters are going to be w1, w0, w2 and other things. To find the values of x and y such that the function attains a minimum, we have this operation. That is, I want to find out the value of the function where it attains minimum. That is, what is the value of the x coordinate, what is the value of the y coordinate. What the value of the x coordinate, t plus 1th iteration. X of t plus 1 means what? Value of x in the t plus 1th iteration is equal to x of t, the value of x in the tth iteration, minus eta into dou f by dou x. Eta is one learning rate. That is a number which lies between 0 and 1. X of t plus 1 is the updated value of x at the t plus 1th iteration. Eta is a small number called rate. In the same way, y value can be calculated. So we want to, so there is no need for your derivative equating to 0, solving the equations and second derivative. Nothing is there actually. But the concept here is this formula, just I am going to use it and show it to you actually. X of t plus 1 is equal to x of t minus eta into dou f by dou x. So now what is the input for it? You should have a function very clearly, and function unknowns are x and y, and we are going to make it up. Here, just I am going to apply this gradient descent updation rule based on that formula. G of x is equal to, this is the hypothesis, error function I am going to compute. If I change the hypothesis, error function will change. So now to find the weights of wi such that E is minimum. So this is k plus 1th iteration, because I am not putting the suffix because suffix is given by w0, w1. So if I want to find out k plus 1 iterative, it is an iterative method, whereas that normal equation method is a one-time method. So once the value comes, I can't improve or decrease or increase actually. So that is the fate. Here I am going to improve, run the experiment, iterate it again and again till I get a correct value. So Wik plus 1 is equal to Wik minus eta into dou E by dou Wi. Eta is the learning rate, and usually the learning rate, it is a number lying between 0 and 1. In all the experimentation, we fixed that as 0.5 actually. So now, what is the thing? One illustration, we will take it out actually. For example, I calculate g of x, dou E by dou Y, I calculate. This calculation comes at g of x minus r into, I am just calculating the w's here. Dou E by dou Wi is equal to g of x minus r, because whole square is there. And and 1 by 2 will get cancelled out actually. And here, why I am making it, so far we are running with n actually. There is a square term here. When I take the derivative, 2 can get cancelled. So what is the thing actually? I am making a change slightly in the function. There is no difference here. For example, see here, parabola y is equal to x square plus 4 takes a minimum value at the point x is equal to 0 and the minimum value of the function is 4. Okay, very good. Now, what you just take y as the x square plus 4 over 2. Where does the minimum value occurs? The same point. Only the minimum value is going to be 2. We are interested in finding the point where the minimum occurs. So x is equal to 0 is the thing. So from now onwards, what I am going to do in the denominator, instead of capital N, I am going to take 2 here. What is the purpose? My comfort zone. The 2 is going to be coefficient in the derivative. 2 and 2 will get cancelled. So how easy the max is flexible for us. So there is no change in the minimum point. In both the things, only there is a change in the minimum value. But here I want the point where the minimum occurs. So point is more important than the function value here. So for that reason, I am making it. So the derivative 2 and 2 will get cancelled out. And I am going to calculate this g of x. I am going to calculate this is coming. So now dou E by dou Wi is what? G of x minus r star xi. So updation rule here is Wi is equal to Wi minus eta into g of xt minus rt, because in the iteration star xi. Xi is what? What is the input variable for the corresponding thing actually. Now, like that batch created, now we'll go to the one small example with the same formula. So I am having x and r, and the x value is 1, output is 1, 2, 3, 4, 3, 3, 2 something. So I choose a very simple hypothesis so that we can understand the model actually. W0 plus W1x. So E is what actually? It is the error created by all the 5 data points divided by 2. Okay, very good. Gradient descent. Now there are many gradient descent formula. This batch made means this is batch made stochastic. I will tell you. Now we are using this formula. Wi is equal to Wi minus eta into other things. Summation, the whole thing star xi. Okay, now initialize the values 0, 0. To compute first iterative values, W01 is equal to W00 minus eta into summation t is equal to 1 to 5, this thing actually. So I expand all the summation using this 5 values. What I do get here is the first iterative value for W0 is 0.14. Then based on that, for W1 I make it out actually. W1 power 1, W1 first iterative value is, what is the old 0th iterative value? 0th iterative value is 0 minus eta into those dramas. I make it out actually. All the things are there. W0 0, 0th iterative value is here. W10 is also, W10 is the initial value. X11 is in the data set. All these values are there. I calculated. Very good. It's the normal calculation. So it comes to W1 first iterative value is 0.5. So what is the initial value? W0, 0th iteration is 0. W1, 0th iteration is 0. What is the E then actually? Based on this W, I can calculate the error value, substituting in the formula. So 196 by 2, 98 is the error when I started with that. Then I calculate the first iterative value, then I calculate the error. That error is 2.4571. Earlier, in one iteration, the error has reduced because of the iteration. It was 98. Now it has become, hope we understand that how we calculate this error value. Using these values, you g of xt, you use those values and calculate for each row. And this is the output. And then multiply with this. So like that, just one few minutes, I'll stop. I understand 15 minutes I have crossed, just 1 minute, I'll wind up. So those things and all, they just get down. Now second iteration, you do it here. The same calculus. And then second, see for example, we started with 0, 0 initial value, error was 198, and E is 2, it's 2 point, it's not 2 comma, 2.4578. Second iteration, I did it 1.254. Like this, we continue the error. But one thing I will have to tell you, this, whenever you find out the values, you just check what is the error value with the earlier fake value. E of W0, W10, zeroth iteration error should be greater than the error in the greater than the error in the first iteration. Like that, it has to go. If it is other way, then what you have to do is just go and control the delta actually. That is the thing. Now coming back to the thing, what is happening here is, here with, for example, I'll go to the final thing, I'll make it out. For example, you have to, this is your objective function and this is the place where you are making. Now you start with one value here, W0, W0, W1, zeroth iteration. This is zeroth iteration. Then based on that, you will be coming to the point here, somewhere here. Then this is the first iteration. Then second, this is the point where you have to reach. This is the magic point, golden point where you have to reach actually. So sometimes, when you come here nearer to it, you just calculate the error. If the error is minimum, then make the eta value, control it. And like that, if you make the eta value strong, the next value will be going here. That is, you are descending from here to here. That is called the gradient descent. And I have to do the iteration in such a way I hit this exact point. That is being depicted in this figure. That is, I start somewhere in the bowl. I have to reach the bottommost point. So with this gradient descent, I slowly come down, come down, come down. I have to control judiciously. For example, while running the Jupyter notebook for this example, there and then as the satellite, ISRO scientists are watching the satellite, whether it is going into the orbit normally like that, we have to have a watch. When we implement a very heavy data set, when we train a good machine learning model, like that we have to make it out till we reach. Sometimes, we will be very near to it. If you say that I want that accuracy performance of 0.01, let me keep mark, that's all. That is being depicted in this figure actually. So here, this is the thing. I started from here, I have to go. This is the lateral view of this actually, bird's eye view laterally. So I started from here, I go inside till I get the thing. And slowly the convergence. What do you mean by convergence? Here I have to, sir, how do I know that it is converging? What is the thing? The successive values will be like in the numerical methods we know. Successive values, what do you mean by, for example, this is the thing. Successive till we converge. What do you mean by convergent? Difference between the successive iteration should be too small. How we stop the iteration in the numerical methods and other things. This is so now what we have discussed here is about the regression. We had the concept behind this mathematics, behind this regression method is minimum value. And minimum value, since the objective function is defined as the bundle of square, where we will be having only one minimum point actually. That minimum point is the global minimum point. So for that, the only technique in mathematics is find the derivative, and the slope of the tangent at the point is 0. So take the derivative of that, equate to that, equate to that. That solving first we did with the manually, and after that with the help of linear algebra. After that, with the help of linear algebra, it is a non-iterative method. Then we did with the gradient descent, calculus, gradient, directional derivative. And direction derivative is a powerful method. This is the gradient descent approach used in all deep learning models based on transformer even today. That is a very powerful gradient descent. That model core concept is this. This is the concept behind that. Are you getting the point actually? So with this, I'll wind up and I expect any questions from here. We expect any questions.
Okay, sir. Respected Dr. L. Jagannathan, sir. You have given a wonderful lecture on mathematics of machine learning. Your voice is clear, very clear. Okay.
Yeah, any doubts? And at the same time, here I remember that
So this is the
when
time
I
for
was in
question and answer session.
yeah, fine.
Because of the large number of participants, any participant who is interested to clarify his or her doubts, please come forward to post it only in the chat box.
Jagannathan sir,
Yeah.
really excellent lecture, sir. Moreover, you explained the concept thoroughly from its roots. You maintain the same tempo and enthusiasm with the same strength throughout the seminar, sir. Wonderful, sir. Actually, your lecture brought back memories of my student life once again, sir. Thank you, sir. Thank you very much.
Thank you. Thank you. Thank you. The only thing, as usual, in then also my talk will be boring. Now also it will be boring for the audience.
No, sir. No, sir.
That
it is
is
wonderful lecture, sir.
Okay.
That is not
Now,
boring, sir. Always it is caring, sir.
And another one, my request to the
caring about our future lives.
Yeah, because the one thing I'll tell you here is, if you implement one machine learning algorithm, deep learning algorithm to fine tune the other things, you should know the concept. If not, the performance, because it is going to be domain specific. As a computer science, you will get a data from health domain. You will get a data from education domain. So for you to make it out, you should have a domain knowledge, as well as if you know the concept, we can tinker this. For example, the control is in the eta actually. Usually we start with 0.5, then we'll reduce to 0.3, 0.2, so that we observe the error calculated there and then. If it is going heavy, then we are going in a wrong direction. If instead of gradient descent, gradient ascent I'm going into. So it is a wrong signal. So, but of course, one thing I'll tell you, these concepts, we have having a very good integrated platform like Jupyter Notebook, Google Colabs and other things, where we are able to experiment and visualize it in a better way. Had it been the normal thing, even in the MATLAB, the size may not, feasible for us. So like that, now, if you understand the concept of any machine learning algorithm, you can do wonders. Mathematicians are going to decide the fate of the, future. But only thing is they should understand the concept behind it. That is the only thing. This computer science people, many of the young professionals, they lack in the conceptual understanding. In my experience, I can tell you very guaranteed.
Exactly correct, sir. Exactly.
I'm teaching the computer science student for the past 15, 20 years actually. So if you are very strong, if you are if you are good in programming and if you are good in mathematics, you will rule the world. See how, having done material science from IIT Kharagpur, he has gone to Google to chart it out. Sundar Pichai. How it is possible? Because he has got a very thorough conceptual understanding. And this gradient descent is applied in the recent AI revolution, fifth industrial revolution that we are facing. This gradient descent is used there also. Gradient descent, the directional derivative concept is a very powerful concept. Only thing, scaling up. Now I have shown the illustration with the four weights or 5 weights. There it is billions and millions. Smaller models will be 7 million. Smaller model, lightweight model they call. Can you get the point? So like that, and my suggestion to the audience is, and I'll give the details. There is one good book for it, Mathematics of Machine Learning. This is the draft of the book actually, and this is one good book available here. I can refer it, refer the detail. I can share the detail, the author name and other thing. If you want to gain Pakka mastery in this mathematics for machine learning, it came in 2019 actually. I'll share the details. and all the concepts are here. What we have discussed, everything is here actually. And my suggestion to the thing, don't depend upon the experimentation alone, because the experimentation, what is the message told by the experiments, we have to understand. How the doctors get the message of the disease through the symptoms told by the patient. Am I correct or not? No doctor can depend upon the lab report alone. Lab report will be 7 or 17. He has to understand what does that 17 interpret. So lab report, if you run an experiment, and because the people have an idea, all the codes are available, all the open source, we can download any model and run it and see the output. Okay, very good, that's good. You can do even now. But for a given data set, if it throws certain value, what is the interpretation? For example, doctor is treating the patient. Suddenly, the patient starts vomiting. He has to understand the interpretation of the vomiting and change his treatment attitude. If the doctor doesn't understand the vomiting interpretation, the patient may die. Can you get the point? So that is the power for mathematics concept in the real-time implementation. If you are good in programming and if you are good in mathematics, mathematics means the concept behind that algorithm. I'm not asking you to master the whole mathematics. Concept behind that algorithm will help a lot to understand, so that you can tinker and make the model successfully learn from the data set actually. So this details I'll share with the book and other things details. That's a very powerful book with all the detailed explanation from where theory meets the data set. He has written one good section that you can make it out actually. So I think any other story, I will not bore it out actually. And before that, before I wind up, I'll make it. I thanks for the opportunity. And when HOD was referring that Raman, my association with the Bapatla Engineering College and other thing, I remember 110th and birthday celebration, I think, 1997.
Yes, and 1997.
110th birth anniversary of Srinivasa Ramanujan, and I was proud to be a part of the thing, and I'm very happy that legacy which we created during that 1997.
Sir, I was also in that team, your team.
Yeah, that's what I remember. 1997 till now it is 137th, I think. 137, 1887 is his birth year.
137th.
Yeah, 1887 birth year, and based on our Ramanujan birthday only, the college also started Engineers Day celebration.
Yes, sir.
So we were the role model, and I'm very happy that the legacy continues. I'm happy to share that feeling with all the Bapatla Engineering College faculty.
Sir, you created a benchmark for us, sir.
And I remember all this, we met with the carpenter, we created a model of all this thing, one big exhibition in the drawing hall. 4 or 2, I don't remember actually.
Sir, actually that was continued more than 1 week also, sir, with the greatness of our president, sir.
That was the thing. And even the construction department, carpenters were troubling with all the things and made it out, and that made a success. And I'm happy that the legacy is getting continued at Bapatla Engineering College. Really thanks a lot, and hope to meet you soon in person actually.
Definitely.
And for the audience, if you have any doubts and other things, Dr. Vijay Sarathi sir can share my telephone number and mail ID, and I'm happy to help you out. And if you have any queries related to AA model, now I'm working with the 3 Government of India project, AA for Education. My theme is related to AA for Education. And if you have any doubts, if you want to work with me as an intern or something, anything, we will be gladly welcoming you. And the first thing is, if the student will give a test problem for you, you learn and solve the problem sitting in your home. Based on the success, we will provide more and more opportunities for you. We are having ample of opportunities, and these things were possible because I could understand the mathematics behind it. Nothing other than that.
Definitely, I will share your number and your
number, mail ID. I won't feel disturbed also. Even if it is the nonsense, silliest doubt, please ask me. We are here to help you out actually, because I have a close affinity to Bapatla Engineering College, and
sir.
Bapatla town also. So if I could help at least 1 or 2 students in Bapatla, I'll be the happiest.
Very
That
nice,
is
very
Definitely
nice.
through your lecture and words, we are able to
Yeah.
remember the days we spent with you.
Yeah, thank you. Thank you.
Thank you, sir. Thank you.
Hope to see you all in person actually. Okay, thank you.
Okay. I think in chat box, students are not posed any questions.
Sir,
Maybe.
please
think we
conclude the
may-
session, sir.
Yeah.
Okay.
Maybe it's to be started by 3 o'clock. The level of
Yes, sir.
retention nowadays is 8 minutes for the average student globally. Maybe after that, when they start learning, they will get doubts. So through this workshop or conference, I'm giving a message. If you want any help, whatever may be the branch, you may be a civil branch, electrical, electronics, AA is AA, ML is ML. That's all actually.
Okay,
For
sir.
every domain that has penetrated in every domain of engineering.
Sure, sir. Sure, sir.
Okay, sure.
Thank you, one and all, for your good response and valuable support. Expecting the same cooperation for the remaining sessions also. Today's session concludes with a vote of thanks by staff organizer Sri I. Pothuraju.
Good evening to all. On behalf of the Department of Mathematics and the participants, I would like to express my heartfelt thanks to our today's resource person, Dr. L. Jagannathan Sir, Professor, School of Computer Science and Engineering, Vellore Institute of Technology, Chennai, who gave such a good and informative presentation on mathematics of machine learning. Despite of his busy work schedule, he gladly accepted our invitation and gave a valuable talk in today's session. Thank you very much, sir. I would like to thank our beloved head of the department and convener of this international workshop, Dr. Kevin Acharya sir, who guided, motivated, and supported us to do this program and encouraged us to shape out today's program. I would like to thank our principal sir and our management, Babat Education Society, for providing us all the facilities and encouraging us to conduct this program. Without their support, it would not be possible to conduct such a program today. I would like to thank Dr. K. Mandeep Karu, Department of CSE, Institutions Innovation Council members, Sri M. Lenin Babu, Faculty of Triple Department, Sri S. Prabhudas, Faculty of IT Department, Sri A. Sai Kishore, and Sri U. Venugopal, who are sincerely extending their technical support to us in conducting this international workshop. Thank you, one and all.
So thanks to all the participants. I have shared the feedback form in your chat box. All of you please fill the feedback form at least in 1 hour or 2 hours before 7 p.m. possibly. Thank you all.
Okay,
Thank you, sir.
Thank
Thank you very much,
Thank
sir.
you. Thank you. Thank you.
Romma nandri, sir.
Jagannathan sir.
Romba nandri. Thank you. Romba
Sir?
nandri. Yes, sir.
Can you hear me, sir?
I can hear you.
Hello?
I can hear you, sir.
Sir, can you hear me?
I
Yes,
can
sir,
hear
yes,
you.
sir. Your voice is audible, sir. Very clear.
Very
Okay, sir. Okay.
Okay.
Okay, sir.
If there are any students interested in working, please pass on. We'll help you.
Definitely, sir.
Definitely, sir.
Definitely.
Okay, definitely. Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you very much, sir.
Thank you. Bye. I'll leave, sir. Thank you.
Thank you.
Thank you, sir.
Sir, end session and